Hi, welcome to another mini lecture on pre-calculus. Topic now is graphing a logarithmic function and finding its domain and range. Very similar to the problem we had in the previous lecture, except that here we are using Alek's graphing utility for doing this thing, and we are not doing it really by hand. We are doing it by the software that's available to us. So, last time we said if you have x plus 2, just like the translation of function we have seen before, this means graph of logarithm is going to move left by 2 units. So you get the graph of logarithm of x in base 2, left by 2 because of this, and up by 1. So that already answers most of this problem. What happens to the domain? It says find the domain and range. Domain is also going to get shifted. The domain of logarithm is from 0 to infinity, so if you go to left by 2, it's going to start from minus 2 and go all the way to infinity. How about the range? Well, if you take all the numbers and increase them by 1, you still get the same set of real numbers. So the range stays from minus infinity to plus infinity. So let's see, how do we answer this problem? As we said, the issue is you are not doing this thing by hand. You're doing it with the tools that are provided. So it says plot 2 points. Okay, how do we plot 2 points? Can I go ahead, put arbitrary x here, use my calculator, find out what that one is, and plot it here? Well, that would be great on a more capable software, but here, when you go to plot a point, you are only allowed to use a specific kind of numbers. Not, for example, you cannot enter a decimal number. You go on your calculator, get a decimal number, you cannot plot it here. So what do we do? So the issue is then choose an x that's going to make the problem friendly for you. What are the friendly numbers? So let's go back and explain this thing in our page here. So we want to graph 1 plus logarithm of x plus 2 in base 2. So the issue is this has to be a friendly number. We don't want the decimal number because our point plotter here is just very simple. So what's an easy number? Well, let's remember, for the graph of a logarithm of a number in base 2, suppose I have x, let me use another letter so we don't get confused here. Suppose I call my input a, and logarithm of a in base 2. So what a's would make this thing easy for me to calculate? Of course, my a's would be 1, 2, 4, 8, or in negative direction 1/2, and so on. Logarithm of 1 is easy. Logarithm of 2 in base 2 is 1. Logarithm of 4 in base 2, 2. Logarithm of 8 in base 2, 3. Logarithm of 1/2 in base 2 is going to be minus 1. So these are numbers that are of the form 2 to the power of some number n, and outcomes here is just n itself. Okay, that is for logarithm of a number in base 2. So now I say this x plus 2 better be one of these numbers. So for example, if x plus 2 is 1, I say if x plus 2 is 1, then I'm calculating logarithm of 1 in base 2, which is 0. So I go ahead, this tells me use x equal to minus 1. Let me write it here. Minus 1 minus 1 plus 2 is 1. Logarithm of 1 base 2 is 0. and I get 1. Let's try this thing again. Suppose I take x plus 2 and I set it equal to, say, 8. So I'm now aiming for the following. Why is that good? Because, okay, so x, I have to choose 6 now. If this is 6, 6 plus 2 is 8. Logarithm of 8 in base 2 is 3. I don't need a calculator for that. That's 3 plus 1 is 4. So we are going to go ahead, use our x's, some friendly numbers. Friendly means when you add 2 to it, finding the logarithm of it in base 2 wouldn't require a calculator, and then you are all set. So let's see, we got this thing right. So we have two numbers at -1 and 1 and 6 and 4. Let's go to our page. So when I want to plot this point, here's our limitation. You can put whole numbers in any of these boxes. You are also allowed to use the letter E, the number E, which doesn't play a role in this problem, but you could have used it. -1 and 1. This point, once we make sure that's what we want to do, we plot the point. In case we change our mind, we can always come back and undo with this thing. Let's try. It says 2 points, so I go and try another one. Notice again here it says do not approximate, so essentially we cannot use a calculator for this. 6 and 4. Plot the point. So that point is here. Well, what happens to the plotting of the asymptotes? We said logarithm has a vertical asymptote when its argument becomes 0. That's where asymptote is sitting. Logarithm by itself, logarithm of x has asymptote at the y-axis. It's x equal to 0. When we are shifting to the left, our vertical asymptote goes left by 2 units. So I come here. Now I go ahead and plot my function, and that would be my function. Of course, now you want to do this thing also by hand. For the domain, we said we are going to be shifting to the left. So for the domain, we start from -infinity. Excuse me. We start from -2 and all the way to infinity. The domain of the regular logarithm from 0 to infinity, we shift it by 2 to the left, so that's how it's gonna be. So the domain is from here to here, set of numbers above or below which we have the graph. -2 itself is excluded because at that point logarithm of 0 is undefined. You are at -infinity. The range, we said going up by 1 doesn't change the domain of the range of the logarithm. The range used to be from -infinity to infinity. This is the whole range. If you lift it, still from -infinity to infinity. So here I have from -infinity, comma, infinity, and with the parentheses. So this was the graph of this. Let's see if we did it right or not. Hopefully. So you go ahead and try this on several problems in this section, and you get the idea. Okay, so until next time, good luck and God bless.